Yes, well, good afternoon to everybody, and thank you again for giving me the opportunity to present our paper. It's always very good to present the paper in which we work a lot, so it's good for us. And the paper called A Neural Network Method for Predicting Fraud and Corruption, Risks in Public Procurements. And this paper have been done with other colleagues, David Blanco, Felix López Iturriaga, and Maria Tremiño. So in this paper, we mainly focus in public procurement. Why in public procurement? Because we know that these procedures are very important and represent a substantial share of world trade. And here in this slide, we have some maybe not very updated figures showing what the general government procurements represent in terms of GDP for some countries. Despite the importance in the economy, public procurements are also considered as a very potential source of corruption. And we have plenty of different news all over the world highlighting some cases. No? Here we have, for instance, 4 anti-corruption priorities for Southern Africa during COVID-19, refined training to tame procurement corruption in Kenya. Now, with the next generation European funds, we heard also some news about corruption in public procurements. So we think that is a very interesting topic to deep dive and to put a special attention on that. Corruption can be found at any of the stages along the procurement cycle, and this procurement cycle displays several steps or stages. We have project identification and design, advertising and bid preparation, bid evaluation and award of contract, and finally contract performance and supervision. And we have here one possible example of one public procurement which consists on the provision of bus service for 5 years with a possible extension of 2 years. Okay, we have also some interesting information like the amount of the contract, the duration, and in some cases it's very relevant, well, maybe the most relevant as well, the award criteria. And in this award criteria, we have several ways of doing, because one procurement can be granted just because the price criteria. It means that the lowest price will win the tender, or maybe what is called the mid or the most economically advantageous tender, which means that fulfilling a set of different criteria, which is the case in this example. We have that the criteria consist on previous experience of the company, the key resources and response times, and finally the cross criterion. According to the European Union, they are more in favor of the mid criteria because it gives a very specific way of assigning public procurements, but also considering different weights for the different criteria. And it is most preferred, this approach, because the price only at the end can make that some companies try to gain the contract just offering the lowest price, but then at the end it is observed some extra cost, and at the end this procurement is no longer the lowest price. Okay, so in this concrete example, we have also the information about the number of tenders received is just 2, the total value of the contract, and also the awarded company. What we try to answer with our paper is this question. Is it possible to detect a list of criteria that were defined to intentionally award a company and therefore restrict competition. So it is possible that price only result in number of tenders with a very low number of companies trying to offer this contract, or is just a combination of different criteria, or are there some specific criteria that are more prone to receive lower number of offers? So this is what we are trying to do with our paper. Okay. So for carrying out this paper, we use data coming from the Tenders Electronic Daily Portal, using information from January 2016 to December 2018. And we have information about more than 72,000 tenders from 33 different countries. So for this amount of tenders, we have the different criteria fixed in the contracts to identify the winners of each tender. And we consider that those contracts receiving lower than 3 offers are considered as a kind of proxy of potential limitation of the competition. Okay, why 3? Because it's a very common number considered as a red flag in the literature. Okay. So we try to deal and to work with this amount of tenders with the list of all the award criteria to create some kind of clusters of topics or criteria, and then see if there are some combination that leads to receive lower number of offers. The process itself is a little bit challenged because first we have the different combination of the criteria in different languages. Not all of them are written in English. Each country can publish in their own language, so we need to translate all the criteria to English. We have then some problems with punctuation marks, numbers, white spaces, so we need to treat and remove them. So, well, it's not so straightforward as is apparent looking the data. Okay, so after the direct treatment of the data set itself, the problem now is how to identify these clusters of these topics of different award criteria. And for doing that, we are using one technique called latent Dirichlet allocation, or LDA, which is a natural language processing technique trying to help us with the identification of several clusters of award criteria. For latent Dirichlet allocation, what is assumed is that each tender set of a different criteria consisting of a mix of different topics. Okay, so we have here one example of 3 tenders. The only award criteria for the tender award is the price. For the second is service, maintenance, and experience. And for the third is the experience and the price. So what LDA is trying to do is just to create a distribution of topics with this itself a combination of different awards. So thanks to LDA, we can be able to assign each tender to one specific topic. Topic understood as a mix of different statistically different number of different award criteria. So how does LDA work? Well, the starting point is just to select a number of topics we think that there are in the corpus. For instance, we can assume in this example that we have only 2. Okay, then LDA randomly assign each word or criteria in its document to one of the topics, and then LDA LDA goes through every word and its topic in each document. And then several metrics are computed, mainly how often the topic occurs in the document, and then how often the word occurs in the topic overall. So based on this approach, the LDA is an iterative process. So at the end, the methodology converts, and you have for each tender to which topic belongs to, and each topic will be a combination of different award criteria. So this is what we have here. What is the result of our approach? Well, first, we identify that the optimal number of topics, what we can find in the dataset we have, is 4. It means that all the award criteria, more than, I did not mention, but we detect more than 10,000 different criteria in all the tenders, okay? So all of these 10,000 of award criteria will be classified according to this technique in just 4 different topics, okay? So we have here topic one, which collect 40% of all the tenders, topic 2 with a 23%, topic 3 with a 23%, and finally topic 4 with a 13%. Okay, so at the end, thanks to LDA, we can build our data set as this point of here, the number 2, a set of distribution of topic for each tender. So for each tender we have in the database, for instance, tender ID number 1, according to the notice of this tender, the award criteria are price and quality. And according to LDA, this price and quality means that the tender 1 can be classified as 80% in topic 1, 12% as topic 2, 5% as topic 3, and 2% as topic 4. So we have this combination or the topic distribution of each tender all over our dataset. And at the same time, we know that each of these 4 topics are indeed a set of distribution of words. So we have here, for instance, in this table at the bottom of the slide, that topic 1, the most relevant words defining this topic are words like technical, quality, offer, price. On the other hand, in topic 2, we have service, criterion, cost, improvement, maintenance. And in topic 3, maybe this is the most different, we have that the main criteria is just the price. Okay, so we can have other minor criteria, but at the end, this topic 3, what is saying to us is that this topic 3 is mainly related to those tenders in which the award criteria is just the price, the minimum price. Okay. Well, this is a good approximation, so we can work with this. So at the end, what LDA is doing is just, okay, we have the complete distribution of and proportions of each tender by topic, but at the end, the topic assigned to each tender is just the one with the maximum probability. So in this case, for tender number 1 in this table, the topic selected will be the topic number 1. Okay, so this is okay, it's a good approximation, and thanks to that, we can compute for each topic the number of tenders granted with the number of offers lower than 3. And thanks to this table, is a simple average. Okay, so what is the average number of tenders with a very limited number of tenders, the offers received? We can see that at the end, topic 3, which is the price related, only price related, or being the most important one, is the one with the highest proportion of very low number of offers received, meaning or being in line with the European Union suspicious about this kind of procurements. Okay, so it's better according to this table, at least to avoid restricting the competition, to foster or to promote to have a mix of different criteria. Okay, so this is what we are trying to understand according to this table. But we need to go one step further, because we think that uh, it's not good to avoid considering the topic distribution, because at the end, this tender one, for instance, is price and quality. We can assign it to topic number one, but maybe it's better also to consider the full distribution. And because of that, we run by considering all the different probabilities. We create a kind of clustering by using one technique called self-organizing maps to to take advantage of the full distribution of our tenders in the sample. Okay, the full distribution by topic. And we can identify 4 different categories of tenders according to the to this technique. Okay, so we repeat the same process, but now we are more precise in our analysis, if I can say. So at the end, what we are detecting again is that the price only criteria is maybe the most risky in terms of restricting the competition. Okay, so this is more or less our paper. This paper indeed has been already published. Okay, so we are happy of that, of course, but we are happy about this paper not just because it was published, because it just opened us the possibility to still further investigate and continue working and to develop one website in which we have tried to collect different red flags um, and to monitor all the database we have of tenders and to collect the different red flags we can identify in the literature. And because of that, we created this website. It calls crystaltender.com. Crystal is like trying to say a kind of transparency, okay? And we have information about, it's a Power BI dashboard, and we have information about the number of tenders being assessed, the type of procedure type. We can filter by the different countries, and we can see in this first dashboard some basic statistics. Okay, but after that, we can identify for each country and for each year um, the amount of red flags we can identify in all the public procurements granted by one specific country. Okay, so we have um, this dashboard which provides a very good information, trying um, to monitor in some way the performance of the different public administration when they grant the different public procurements. Okay. So well, I think this is what we would like to present to you. Um, I, I hope you can have the opportunity to visit the website, and you could see in the website that it's not very updated because thanks also to this platform, we realized that it's very time consuming and technologically demanding to have updated this website. So we learned a lot, and we now are participating in developing other kind of approach, but more focusing in the use of the European funds, the next generation European funds. And we have the idea to update this information, but looking some ways to automatize the process to keep live this kind of projects, because we think that is very helpful for the community and for the public in general. So again, thank you very much, and do not hesitate to contact us if you have any kind of doubts.